Okay, so these patterns are made of sticks, and you've got pattern 1, 2 and 3 shown. And it's asking you to draw pattern 4. So the first thing you need to do is have a look at the visual. Can you spot what's happening? So if you look at it, we started with 4 sticks making a square. On the second one we've got the same 4 sticks, and then we've got another 3 sticks added to make another square. And then on pattern 3 we've got the exact same one from so same from pattern 2, but then we've added another 3 sticks to make a third square. So for pattern 4 it's going to be the exact same as pattern 3, and then we're just going to add on an extra 3 sticks to make another square. So art's not my strong point, as I tell you all the time, but I'm going to have a go. Pop some sticks down for the first one, then down for the second one. Oh, see, I messed it up already. Let's go back and then show the next one, and then the next one. So that's pattern 3, almost. I'd get your ruler out. And then the next one, I just need to add on 3 more sticks to make another square. So you can see there's 1, 2, 3, 4 squares. Here there was 1, then there was 2, then there was 3. So as long as it looks like that in the exam, you'd be getting the marks for it. If you really wanted to be sure to get it right, you could even get your tracing paper, copy that one down, and then just pop an extra one to the side of it, which I'd probably do to make sure it looked as best as it could. So how many patterns, sorry, not how many patterns, how many sticks would there be in pattern 10? So this is pattern 1, 2, 3, this is pattern 4. So before we can answer this question, we now need to think about how many sticks are in each of the patterns. So in pattern number 1, there are 1, 2, 3, 4 sticks used. So I'm going to make a number sequence to help. In pattern number 2, there are 1, 2, 3, 4, 5, 6, 7 sticks which are used. In pattern number 3, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 used. And I've just done pattern number 4, so let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 sticks to make that pattern. Now, it's much easier to look at the number sequence now to work out how many would be in pattern number 10. So 4 to 7, what is the difference? How many sticks was we adding each time? If you remember when I was doing the picture, when I said it add 3, you add 1 there, 1 there, and 1 there. So that's adding 3 sticks in to get your next term. Then you add another 3 sticks in to get your next pattern, and then another 3 sticks to get your next pattern. So we've got 1, 2, 3, 4 already. We want the 5th, 6th, 7th, 8th, 9th, then 10th to know how many sticks there'll be. And we just keep adding 3 patiently each time. So I'm going to add 3 to 13 to give me 16, then add 3 to get to 19, then add 3, to show it, sorry, then add 3 to get to 22, add on 3 to get to 25, then I'm going to add to 25, I'm going to add on the 3 to get to 28, then add another 3 to get to 31. How many patterns will there be? How many sticks will be in pattern 10, 31? Now, for those of you who are really good at nth term, there is an easier way. You didn't have to necessarily carry that on, but patience will definitely 100% get you the right answer, because 31 is the correct answer. But if you're good at nth term and you know what this sequence is called, anything that goes up in 3s is like the 3 times table, which is 3, 6, 9, 12. And the posh nth term for the 3 times table is 3n. Feel free to go and watch the nth term videos first and then come back to this if you'd like to make more sense of it. The sequence we've got is 4, 7, 10 and 13 is not the 3 times table. It acts like it, but it's not the 3 times table. It's just 1 ahead of the 3 times table. If you are 1 ahead, then you add 1. Look at each example. 9 add 1, 12 add 1. The nth term for this particular sequence is 3n add 1. So if we wanted the 10th one, we want the 10th position, the 3 lots of 10. So the 10th one would be 30, but we need to add 1 to be 1 in front of the 3 times table. So 31, same answer. This one involved a little bit more mathematical thought, but if you know it, use it. Okay, so another example, just in terms of the patterns, just so you can see a different variation, is dots. So pattern 1, 2 and 3 is shown, and then you just need to spot what's happening. Continue the pattern to show number 3. So we've started with 1 in the centre, and it looks like there's then been 1 added to each corner. So let's see if I can try and show it. So 1 in the centre, and then we've got the same 1 in the centre, but then you've got 1 added to each side. So you've got the same one again, and then 1 added to each side of it. So it's like the corners, like the number 5 on a dice, and then this time we've just grown again, another 1 dot has been added to each part. So if you're not good at this, again, you can copy the one from before. So there was 1 in the middle, and then make the number 5 dice, and then to get pattern 3 you just need to add 1 to make that line extend, and then so that's pattern 3, and then just add another 1 to each side to extend it even every time. So every time you're adding in another 4 dots. So that's that one. Hopefully you can see it, so if not I'll make them a bit clearer now. So we had that one, and then 3 that way, 3 that way, that way, and that way. So take your time with it. Again, you could trace around that in the exam and then just pop an extra dot at the end of each one. So how many dots will there be in pattern 6? You could then, so this is pattern 3, pattern 4, you could carry the pattern on to draw another 2, because you've already got this is pattern number 4, or you can use that diagram, and then if you know the next one is going to be, add another one, so that's going to be pattern 5, that's going to be pattern 5, and pattern 6 is going to have another one on each end. So you could cheat and just use the one you've got and add another 2 dots on and then count them all up. So let's have a look at that. Count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. How many patterns would be in that? 21. Now, it's not the best method. There are other methods, so let's have a quick look at it. It's all about knowing how many dots are in each one. So in pattern 1, there is 1 dot. In pattern 2, there are 5 dots. And then in pattern 3, there are 5 plus the other 4, so 9. Now, the good thing here is you can actually use this sequence and have a look at what's going on, or visually see it through the picture. Each time you add in 4 dots, so we can see that pattern will continue. So add 4, 9 add 4, 13, add 4, 17, and add 4, 21. Okay, so if we have a look at part C, and it's going to start to get a little bit more complex now, so you really do need to make sure you've understood everything so far. Question C is asking us which pattern will use 77 dots. So if you were super patient, you could carry on this sequence until you got to 77. But it's not the best technique going. So like in previous videos when I've spoke about nth term, this sequence that we were looking at, this one, we can work out what it is called. So it goes up like in 4s, so it's like the 4 times table, which we call 4n. And it isn't the 4 times table because we know the 4 times table starts at 4 and then goes to 8 and so on. So the difference between the 4 times table and our actual sequence is our sequence is behind it, which means we're taking it off, and it's behind by 3, so it's 3 behind. So this is what we call the nth term for a sequence, and that's for our dots, as you can see above. So if we want to work out which pattern uses 77 dots, this is where the complex bit comes in. We need to know when does this sequence equal 77 dots. And now we're bringing in the balance method. So if you're no good at balance, you might want to brush up on your balance skills. And there's videos for that as well. So we're going to use the inverse operation. Instead of taking away 3, we're going to add 3 to both sides. That's going to give us 4n still, and that's going to be equal to 80. So 4 lots of something equals 80. You can either divide by 4 or think what that number must be to work out what n is, and that'll tell you the position. And then 80 divided by 4 is going to be 20. So if you were patient and carried the original sequence on, keep adding 4, you would eventually find out that when you got to the 20th position, you would have got 77. But this is a more efficient way of doing it. So which pattern uses 77 dots? Pattern number 20. Explain why there will be no pattern that uses 200 dots. So this again, really challenging, making sure you understand it. You need to use your nth term, so 4n minus 3, and say, well, why does it not include 200 dots? So you need to try and solve it to prove that it can't be 200. So if we do the balance method again, add 3, 4n equals 203. Now, if we do divide by 4 to get n on its own, divide by 4, 203 divided by 4, if you use your calculator or if you took your time and you were good at another method of division, would get you 50.75. Now, in order for it to be in the sequence, it has to have a whole number position. So n is 50.75, so it cannot be in the sequence.